Perfect. Well, thank you very much for joining us, everybody, and just giving of your time this afternoon again. This is the second and last day of our workshop. And I think what I'll do today is I'll do a quick summary of what happened yesterday. And again, just kind of go through what we think the goals are, just based on some of yesterday's discussion and some of the great initial feedback that I've already started receiving. I'll outline some steps that we want to take next, and I'd really like to come back to this at the end of the presentations today, and just as much as possible over Zoom, do kind of a bit of a group think and see what how we want to proceed next. And I'll give a few suggestions. So let's just jump straight into it. So just to remind everybody, here are all the various bodies and entities that deal with space. This is just a small fraction, right? This is not complete, but you can see the various departments, the various centers. We have National Plasma Facility. We have student groups that do rocket launches. We have propulsion, and of course, a ton of science that deals directly with the science of the near Earth space, right on top of our neutral atmosphere, and going right out to the planets, the moons, right up to the surface of the sun, if there's such a thing. And the mission and the vision statement, as I see it, is the Space Institute is going to be an interdisciplinary and interdepartmental community. It's gonna have to be interdepartmental because people are just in engineering and in sciences and in various departments. And I don't think we can create a single department that kind of holds together all these various activities. So it's going to have to remain an interdepartmental activity. It's going to be faculty, of course, the great body of researchers, students, young scientists, whose common goal is the elevation of space science and the basic elements of the Space Institute as we envision them right now. It's going to be fundamental research, fundamental space physics, that's the first bullet point, based on this kind of research, basic research and exploration of various regions of space. And secondly is technological innovations in engineering technology, spacecraft propulsion, instrumentation, and this will have a pipeline to entrepreneurship. So very much like the Moonshot program, you know, the kind of very intense scientific pursuit had to force a bunch of technological innovations, and a lot of entrepreneurship came out of it. And we hope to do, you know, some small version of that, hopefully in the Institute. The third point is education. And as was pointed out yesterday repeatedly, there is a need for a workforce. The aerospace industry is the #1 employer in the Southern California region. There's a huge demand for manpower, and this is, of course, our main product as a public university. And that leads me to the fourth point, the tight integration with the Southern California space community. And this is where you all thought leaders come in to basically tell us, how can we do this right? How can we serve the aerospace community? You know, what kind of things would be the most relevant and beneficial that we can be doing to support the aerospace industry in and around Southern California. So that's the initial plan, that's the initial vision, and I assume this will mature as time goes on. A quick recap of day one, and I'll just quickly run through this. So we had several speakers. I introduced the mission and vision. Marco Velli told us about our place in the universe and just kind of the targets for space exploration. Vasilis Angelopoulos talked a little bit about innovation and how we set new priorities, and kind of touched on this idea of education with CubeSats. It's kind of a very unique thing that we can do. We don't only teach with regular classes and textbooks, we teach in a holistic way. This is what I meant in my previous slide about holistic education, not just textbooks or writing computer code. You can actually put people in projects. You can make them part of CubeSats, of missions, building instruments, being involved in large projects that UCLA as an institution is involved in. That's kind of unique for us. Krishan Khurana talked about the untapped potential of our very large researcher community in teaching and innovation. Brian Eaton talked about the VC community and kind of this value of connection through various partnerships. I think this is what Brian has done in his career extremely successfully. John Arenberg gets a special slide of his own, which I'll talk about next. And Jeff Scheinrock talked about the large potential of connecting Anderson groups with these science and technology groups. And asked a couple of questions. How should we take this forward? And how should we use the funds? Assuming that funds materialize from various entities along the way, what would be the best and most effective use of such funds? In which direction should we go? And this is what we'd like to pick your brains about today. So coming back to John Arenberg's slide, here I have, it's not exactly courtesy, I've liberally stolen from John because he articulated this so well. This is why John heads multi-billion-dollar missions and I don't. So I feel I'm justified. So John said that aerospace is a large part of the California and especially Southern California economy, and it runs on people. And so there's a strong educational need. That was point one. Our space projects are highly disciplinary. So this is what I just said. The demand is for more than the usual suspects, more than just people who are versed in physics or just in engineering. And my comment below that, see, I'm editorializing in orange, is that we can do more than the standard classroom education. This is what I just said. We can teach people with regular classroom instruction, but then involve them in CubeSats, actually like really involve them, make students project scientists and leads on various parts of missions. So they take responsibility for it. Instruments, CubeSats, projects, and of course, something that I feel like we can uniquely do is we can involve students in industry exposure. So we can get students summer jobs, for instance, in and around Southern California in our partner industries, in the labs, in the companies that surround us. John says in the next point that the Space Institute is a great idea and overdue, and I think he said it's a pity that we're not celebrating the 20-year anniversary of this institute already, which is kind of a fun take on this. No matter what direction is taken, there's ample room and there's great enthusiasm for cooperation. The Institute is designed for the mutual benefit of the entire community. And I think that's exactly right. We as educators want to do a great job in training and teaching our students for the market. And I think you, the aerospace thought leaders, essentially the market for our students, can tell us exactly what you need, and we can really optimize how we do business at UCLA. And the industry will be excited and enthused and want to engage for many reasons. It depends on the direction of the institute. And so this is what we're figuring out. We're taking the first step to figure this out. Okay, so this is my last slide. And today we're of course in day 2, and you can see the lineup of great speakers that we have today. Eric is speaking next, and Ardeen, and then Brooke, and so on. And so here are a few next steps. And so I want to plant these seeds in your mind, and I'd like you to be pondering this over the next hour or so, because we're going to close, and I'd like to take just kind of opinions and thoughts and ideas about our next steps. But there are a couple of things that I see. So firstly, a few things internal at UCLA. So our dean and I agree that the opportunity is now. So waiting until we have met several times and then starting to move, it's probably not necessary. The opportunity is now, and I think we can start moving in some areas. One of those is creating a website that starts to organize all the people and activities at UCLA, and we can start doing that very soon. And in the meantime, we can be working on an expanded prospectus. You saw the one-pager that we sent out, hopefully, that just gives you a quick summary and an overview of the basic concept. And I think we can start thinking about bylaws, people involved, kind of a little bit more detail, and start developing those kinds of things. We can start doing that essentially immediately. The next thing is we'd like to schedule individual meetings. So if you're willing to have a chat offline afterwards, I'd love to schedule one-on-one individual meetings, get your thoughts and feedback. I know that some people that were on the line yesterday who were very quiet, who didn't say anything, actually, when I pinged a couple of people, had fantastic thoughts and fantastic feedback. And I'd like to just create an avenue to be able to share those kinds of ideas. So we'll be reaching out to you. Don't feel obligated, but if you're willing, we'd love to get together and chat, as well as who should be involved. We thought of kind of the best people to be involved. That's you folks, and we might have missed a couple. So please let us know who might have missed. The third point is it probably makes sense to have a next workshop relatively soon. While the idea is fresh and while we're getting all our things together and right after we've had a chance to meet and discuss individually, it probably makes sense to do a next workshop kind of like this, but maybe a little bit more workshopy. So this is just an idea. Think about it and let me know towards the end of the meeting. But we're thinking about something like this in about 4 weeks' time. The additional people that we have left out this time accidentally, we would invite again. And we'd probably make it a bit more workshop style. So have less scheduled sessions and more sort of, here's a breakout for half an hour, discuss a particular theme, and then let's get back together afterwards and kind of talk about ideas. Just have it a lot more interactive the next time. Now that, we all have an idea, basic idea of what it is that we're talking about. And of course, number 4 is just a general point of creating a plan forward. So the Institute itself, what is the scope, what are the functions, and how do you step-by-step implement it? We're willing to just go ahead and start taking initial steps forward, assuming that parts of the puzzle are just going to figure themselves out and then we'll be able to kind of get it together as we go along. We think that's probably a good way to do it, right? If you build it, they will come, I think is the philosophy there. We will get together, I think, a board of advisors. I think it probably makes sense to already, I know that there are a few people who are already very passionate and interested and have a vision for how this should function. And I think we can start getting an initial board together and then just figure out the kind of the nitty gritty, what's a fundraising plan? What's an educational plan? How do we make that happen? So that's down the line. So that's all I had to share today. Let's see how we're doing for time. I'm a little bit over time. Any comments or questions, Miguel?
I just want to take a moment to introduce Eric, if there's no questions right now. Okay. So, we were talking multiple times, as Jacob said, about, our mission as a higher education institution, a research-based university is, the generation, the creation of talent, and in particular, the creation of a workforce, the development of a workforce. In this particular case, one that is a very high-tech, entrepreneurially savvy workforce. So it's, I think that's kind of the vision. And there is a number of analogies that exist between the landscape for space science and exploration today and what has been going on also in the last few years with quantum computing. Our colleague, Eric Hedson, is from the Physics and Astronomy Department and is the co-director of the Center for Quantum Science and Engineering, which is a joint venture between physical sciences and the School of Engineering. And Eric has experience in the development of a self-supporting degree, a master's degree program on the field that was just approved by the Office of the President of the University of California. Eric, please tell us about your experiences on the development of this master's program.
Thanks, Miguel. It's okay, I'll share my screen because it's just easier for me to speak over slides. Is that okay, guys?
Perfect.
Okay, awesome. Yeah, so my, just I guess sort of the disclaimer before this is I just planned to speak to my colleagues sort of, without a lot of flowery language to tell you about how things really went, because I think that would be most useful to you and how we really got here. So as Miguel said, we just had approved this Master's in Quantum Science and Technology, which is a self-supporting degree program that will be housed in the physics department, but in collaboration with the CS department. I sort of thought if I were in your shoes, I would be wondering, like, why would you do something like this? How would you do it? What is it? And is it really worth it? Like, those are probably the questions you're struggling with. And so I'm going to try to address those as quickly as possible. So the why is pretty interesting. In Christmas of 2018, we had a little present from the former administration. That was the National Quantum Initiative Act, which brought a couple $2 billion into the quantum sciences. which was already a field that, wasn't exactly poorly funded, I would say. And so this allowed us to set some pretty far-reaching goals. The NQI, as we call it, was really driven by these sort of 6, they were called policy opportunities, but they were understood to be, this is how everything that's done under the NQI will be evaluated. And I've highlighted in black the 2 that really jumped out to us. Of course, you have to respond to all of them, but we felt for these, we had a chance to do something a bit outsized here at UCLA, just sort of exploiting, our natural advantages. The first is there is a real lack of a quantum smart workforce. That is one of the chief problems for the field, is that this stuff's actually pretty hard. There aren't that many textbooks you can learn it from. And so it's really just done by a handful of PhDs. I mean, there's probably, I would say, some companies have counted and say that there's like 500 real experts in the entire world in this. So there's a big push to grow the workforce. UCLA, as the #1 public school in the nation, we sort of took this as our motto and our charge to address this. The other thing that it sounds similar from what I heard in the introduction is we're very fortunate to be in Southern California, where there's a large part of the quantum industry. And so deepening our engagement with industry, which we already had some, but going deeper with that, both on the research front and the education front, were things we wanted to be very purposeful about. So how did we get started? Well, this is maybe a little bit of background, but I think it's important to sort of understand the stage. We knew the NQI was coming in advance, and we worked with UCLA government relations people who are excellent, and arranged a few days of advocacy to help with the push to get the bill over the final hurdles. And so we actually were there a couple of days, actually during the Kavanaugh hearing, if you remember that debacle. It was pretty wild being there. But it was a really good experience. I mean, we've met with lots of Senate staffers, a lot of House staffers, and they were all really genuine people, really trying to learn. And I actually felt like we did a lot of good. And we also sort of raised the sort of notoriety of UCLA there. So coming back from this, we began working in earnest to set up this master's program. And this is just kind of a rough timeline of what happened for us to give you an idea of how it might go for you. So in late 2018, early 2019, we began planning in weekly meetings a Master's of Quantum Science and Technology. This was a committee of about 8 faculty, if I'm remembering correctly, from engineering, computer science, math, chemistry, and physics. And we met weekly for almost 9 months, I would say, maybe more like 7 or 8. But the plan was to originally host it in an IDP, an interdepartmental program. So the Center for Quantum Science and Engineering is a very cross-disciplinary entity. And so it felt natural to us to host it with an IDP. We decided that was impossible. And I think you will come to that same conclusion as well. We could talk about why that is. The cost of that it's just too high without a lot of investment from somewhere else. And so what we decided to do was change to a physics-hosted master's. So this is hosted in the physics department. This solves lots of financial problems. It also solved a couple of pedagogical problems. And then collaborate with the CS department formally to fill the couple of classes that didn't really fit in CS or in physics. So following that, we then went on to have sorry, my son needs me, I think. I think he's okay. Sorry about that. Working from home, right? So we then went on to work with Kavli to form a workshop to really delve into what a quantum smart workforce ought to be. And this was really important. We invited people from all over the world that were interested in this problem. We spent 2 days, and it was a very authentic workshop where people were just sort of brutally honest about the challenges they were facing and what they thought would work. And that really helped us, I would say, put the final touches on our plan. And so then in early 2020, we submitted our proposal to UCLA. It was approved by the fall of 2020. And then we were just approved by UCOP last month. This timeline here from submitted to approved, I think it would be hard to do any better than that. I would say, in fact, we called in several favors to get that done. There's a big chance for easily losing 6 months or a year because certain committees just don't meet that often. And so you have to be very diligent with that process, which can be frustrating because, you know, at that point, you've already done all the hard work and now it's just getting it through committees. So watch out for that. So what is the program? Briefly, it's a year program. The backbone is 3 laboratory modules that'll be, roughly speaking, in quantum optics, quantum sensing, quantum devices. The reason for this is that at the master's level in the quantum sciences field, you're not going to produce people that are leading the groups. The intellectual challenges of the field really require someone with a PhD. We decided not to produce, you know, to try to scale up our PhD programs because A, we didn't think that was very feasible. And B, you know, I mean, we're already sort of producing people that are pretty good. But with a master's program, that's not something we normally do in physics. And there's a big need for master's people, but those people will be in the lab, you know, doing actual work. And so it's just as important that they understand the equipment, and maybe even more so than it is that they understand the quantum concepts. And so that was our way of sort of ensuring that an authentic education for this. There's a summer capstone project where ideally they'll be doing an industry internship that will hopefully help with job placement. So, all right, my last 2 slides. Is it worth it or was it worth it? You know, we're still early, as Miguel said, we just had approval. We're taking our first cohort next year. What I can say already, though, is that because we acted early on this and because our program, to be honest, is much more authentic than some that are out there, we are seen as a leader in this field. So whenever there's a panel anywhere, someone from UCLA is there, you know, I think helping to craft the field. The other thing that has happened is for our local industry department, local industry partners, we're really engaging now on a different level because we have something that's really important to them. It's very hard to hire in this space. And now they have a pipeline to people that want to be in Southern California and want to work in this space. And so they're much more willing to invest heavily in what we're doing. It is, I hope, we don't have data on this, but we have a suspicion, and I guess maybe it's just hope, that this will be a way to really diversify the workforce. And I'm basing this on my anecdotal experience as a professor over the last decade or so. I've seen so many students that have leaked out of the pipeline because the opportunity cost for a PhD just wasn't something they were willing to accept, you know, but you couldn't get a master's in this field. So our hope is that this will be a chance to grab a group of people that we would otherwise miss and pull them into the field. It's had a very big impact on our ability to attract really competitive grants. You may have heard about the National Quantum Initiative. Sort of one of its centerpieces is to establish 5 institutes to lead the nation in different aspects of quantum technology. We're a major part of the one established on quantum computing. Interestingly enough, there's another group of UCLA professors who weren't in this group that are CQSE affiliated, and it looks, they have made it very far in the final round, and they've sort of received those NSF emails that say, hey, please clarify your budget, which usually means good things. So we would then be the only institute in the country to have landed 2 of these, which would be sort of a coup. It's also been sort of a nexus for our faculty. You know, having this thing that you have to do together has been a glue. And I will say, it's really been fun to get to prepare these more specialized courses. And that's really, it's already fed back into our research. You know, you get the time or you force yourself to sit down and develop lectures on things that, you know, only your group really knows. And that has a big positive impact on what we do. And then the final thing to consider is it is a profit center. You know, the fund, these SSDPs can keep their revenue, keep some portion of the profits. If we are training about 30 students a year. It'll come over to somewhere between $300,000 and $400,000 of profits that go to our physics department to do whatever we want with. So is it worth it? Right now, it looks very much like it was one of the better decisions we made. But we haven't actually rolled this thing out yet. So maybe ask me again in like a year and a half, 2 years. All right, thanks guys, and I'll stop there.
Thank you, Eric. That was really interesting. So any quick questions for Eric at this point? Yeah, Jeff.
So I think you answered it in your very last comment, but as you were going through this, my question was, how many students, I think you said 30 is your goal for the cohort, is that correct?
So our plan is to start with about half that and then scale up. But yeah, by the end of, I think by the third or fourth year, we plan to go to 30. And at that point, we're really covering all the expenses and starting to get into the part where we're making a decent profit. If we were to double to 60, the profits would be much more than just 600,000. So
do you have any indication of how you're going to attract those students?
So and I guess indication, maybe I don't know exactly what you mean. We plan on some advertising. I'm not terribly worried about it because since we've put that this program is going on the CQAC website, we get many emails about when can I sign up. And within our field, it's sort of a known problem that several institutions are working on. So people have tried to do studies to say how many candidates are out there for this. I sort of take them all with a grain of salt, but it feels at least like the student population won't be the problem.
Okay, maybe to keep, go ahead.
No, I was just gonna say one more thing. If you guys are considering something like this because you are a hardware forward field as well, you might also think about a hardware-based master's. And I will say the one downside of that is scalability, right? If you're teaching a data science master's, you can teach 1,000 or 10, but with this, you really have to, scale up your lab. But for us, it was just the authentic to do. So we just decided to just bite the bullet.
Right. So Jacob, maybe if you don't mind, I just go ahead and transition. I think I need to talk about diversity, right? Eric already touched a little bit about that, and we've been talking about it since yesterday. I hope I will not take my 5 minutes, but maybe I'll start by briefly thinking about what are the drivers for diversity, right? Today. I think, as I think about it, I think the first and foremost driver for diversity today is social justice. I think we have become acutely aware that our society requires to do significant work in making sure that every woman and every person of color who desires to pursue a career in science and technology have the opportunity and access to develop their full potential. I think I would just put it like that, right? So that as we look at our community, I think we are still lacking representation of many groups of our society that need to have a place at the tables. That's what I would call social justice. But perhaps more importantly is the fact that it is well recognized. I think all of us have read about it, and many of us have experimented, that diversity is something that starts with people but expands in all dimensions, right? So you start with a diverse group of people, and that really touches on every part of their activity and their thought process. So by that I mean, a group of people that represent all aspects of our society will be able to develop the questions, the challenges, and the answers, the hypotheses that will respond to the needs of our full society. So diversity in all dimensions means every one of us, all of us, right? Means people, of different ethnicities, people, of different, with different sexual orientations, different physical abilities, different languages, different disciplines, different subdisciplines. So we really all expressions of diversity. So, why UCLA? I mean, UCLA is a really special institution, and many of us do not realize it until we hear some of the facts. So I will start by reminding all of us that UCLA has about 160,000 applicants for our undergraduate programs. 160,000. We are the most applied to university in the United States. We will out of the 160,000, about 7,000 of them will come as freshmen, and about 3,000 of them will come as transfer students. So the rate of success is therefore about 1 in 16. So what that means is that our application pool is just so deep that our recruitment office is able to use literally every variable beyond the traditional metrics used by most of our peers. So we may or may not use GPAs and GREs and AP courses and things like that. We use those, and of course, our students are absolutely at the top of every one of their institutions. But not only that our admission process selects also for a wide range of life experiences, community engagement, leadership, hardship, dimensions that many other institutions simply don't have the luxury to look for. Now, I don't know if you know this, but 92% of our students complete a degree. This is as good as the Ivy League schools, except for Harvard. Harvard is about 96. But 92% is about the best for any institution. That means that every student 92% of the students who join UCLA have all that it takes to complete a bachelor's degree, bachelor's in science or bachelor's of art or other degrees. So the success rate is just amazing. About 50% of our students have financial aid. 50%. About 30% of our students are first generation to go to college. About 30% of our students are on Pell Grants. And about 30% of our students are URM. Of course, these are partially overlapping populations in different ways. But what you see here is that we have arguably the most diverse and talented student population, maybe not only in the country, maybe in the world, right? So we could analyze our student population, in many different dimensions. And I think what you will find is that we do have the talent in our campus that just represent every aspect of our society. We are truly an engine of societal change. And I think that is really amazing at UCLA, right? When you look at the majors that contribute to the field that we're interested in here in particular, to space science, exploration, and engineering, well, obviously we have the degrees in engineering, but in physical sciences we have majors in planetary sciences, in astrophysics, in earth and environmental science, obviously atmospheric and oceanic sciences, geology, geophysics, engineering geology. And then, of course, we have mathematics, data theory, financial mathematics, right? So I think the wealth of talent here is just really unique, and I think that is very exciting. Now, the support of this talent is a significant challenge, and my colleague from the Mellon, Brooks Sanders, will talk a little bit about some of the strategies that we use to engage the community and help us make these incredibly talented groups successful. So I will stop there, but I think the numbers kind of speak for themselves. I'll be happy to answer any question that any of you may have.
Not a question, but just to say that's really neat. It's very inspiring to be a part of it.
Well, maybe why don't we just transition to Brooke?
Hi, everyone. Good afternoon. It's nice to be here. So I'm Brooke Sanders. I'm the Executive Director of Development for the Physical Sciences Division, and I've been at UCLA for almost 10 years. In my first role, I was working all across campus fundraising for multiple areas. So I've got colleagues all over the place. So I always get excited about working on initiatives that are interdisciplinary and span a large group of people at UCLA. So within my team, we are fundraising for the division, but we've got a few different people that I think could be really helpful in an initiative like this. So for example, we have a communications person, Lisa Garibay. We have an events group that's really wonderful, and Jennifer's on here right now. And what we are able to do is engage with our community. We're so lucky to be in Southern California, to be in this amazing city that we are. And really, there's just an incredible amount of potential and an audience that's really hungry for science. So it's been really wonderful to work with this community that we have, and we're very fortunate to have it right in our back door. So I think in communicating what we're doing, some exciting new things, bringing more allies and more people that are just interested in this, it gives us a lot of potential in, not just supporters, but really bringing in some people that are interested and could help us fundraise for something like this. So in my experience, I've worked on fundraising for institutes and centers at UCLA and other universities, and I think and this does take some time, but in setting it up for success, creating a healthy endowment so that we're able to plan for the future is a wonderful way to do it. It's something that I worked on with the Institute for Theoretical Physics at UCLA, and building an endowment that allows us to have student support, undergrad, grad fellowships, and also faculty endowment chairs, administrative chairs, that kind of thing, really help us plan for the future. So, and looking through, we have a really amazing population of alumni for UCLA. We have almost 500,000 alumni. We recently, we're just coming off of a capital campaign where we, our goal was $4.2 billion, and we raised just under 5.5. So, but there's still so much more potential. And I think that's the key here. So having some goals to create endowments and current use would be really beneficial with an institute like this. Let's see, what am I not touching on? A way that we, in working with new areas like this, something that we would do is events and communicating the type of thing that we're trying to achieve with this, making sure that people are aware all across the board. There's been mention about putting together an advisory board, so I think that's incredibly helpful. Workshops like this are helpful. So I think there's a lot of potential. We have a corporate and foundation relations group, so I think bringing foundations into the fold are really helpful with fundraising for research like this. And yeah, I think, Miguel, you wanted me to touch on what the endowment levels are. I thought that might be helpful, so let me get that up here. So at UCLA, our Regental and Foundation endowments, we have $6.5 billion. Within the Division of Physical Sciences, we have $161 million. The Anderson School, I thought that might be helpful, is $379 million. And the School of Engineering is $178 million. So we certainly have a lot of potential. What I always love at looking at this is that we are competing with Ivy Leagues with a much higher endowment, and we're doing some great things, but of course there's always lots of potential and more work to be done. So my team and I are here to assist, and I'm happy to answer any questions if anyone has anything right now.
Hey, Brooke, as we get organized and start moving forward, any tips, perspectives we should be mindful of? I know you've highlighted some of our goals, endowment, allies and stuff like that, but as you've seen other centers be developed at the university and possibly elsewhere, best practices we should keep in mind, things we can do now that will be super beneficial for us later?
Yeah, I think engaging a core group of people to help us navigate through that process is really helpful. I think we've begun that. Um, in looking through our current prospective donors, our current donors, finding those opportunities for synergies where there's already some interest, that's obviously a really wonderful place to start. But I can help navigate through that process. When things are interdisciplinary, there's potential across the board, I think, within UCLA and beyond. So I can help navigate through some of anything that might come up that might be a little bit sticky at UCLA. Does that answer your question, Fritz?
Yeah, I'm just thinking, as as Jacob mentioned, as we start thinking about next steps and all that sort of stuff, are there things we can do that are more, it's like you said, synergistic for potential donors, right? That get them excited about what we're doing.
Yeah, something that has worked well, and Meg, I'll let you chime in too, is getting together a group of people who have supported things like this in the past, doing, we call them salons, and just sharing some more information. Jacob has been presenting with some of our other faculty to a larger audience so that we could see where there's some potential and excitement. Yeah, I think doing more of that and very strategic in some of those next steps and bringing more people to the table would be ideal.
Yeah, I would just add that I think the final and ultimate goals of science, of space science exploration and engineering are very compelling to all of us as human beings. So I think it is up to us to project our vision and our ambition and how that might bring benefits to our society, and just make that available to more and more people. And that's something that I think we have been doing and we will continue to do.
Yeah, I think if there was a 5-year-old test, like you take a 5-year-old boy or girl and say, so what do you think of this? And if they get excited, and then we know that we're onto something. Yeah. And certainly are excited with what we're doing.
Well, I have a 5-year-old, so I could do that.
I like the 5-year-old test. I also like what Eric had to say. Since we're in workshop mode, I can get on my pedestal. But this idea that when you create this self-supporting degree program and you kind of show that you have a valuable product, like right off the bat, I think our industry around kind of pays more attention to that, because you're suddenly starting to supply something that's very important, the lifeblood of the workforce, right, as John pointed out. So I kind of see those two things moving in synergy. But to get it started, of course, you do need to raise some funds just to get it off the ground. So yeah, definitely appreciate your perspective, Brooke.
Okay, I think Richie is next, right?
If there's no other comments or questions, yeah.
Yes,
Are you ready?
I'm ready whenever you are. So
Go for it.
Do this. I will share my screen if I remember how to do that. Okay. Now I'm invariably going to ask if I'm sharing the correct screen. Are we good?
You're good.
Okay. So it was funny. I was inspired by yesterday's talks, and it made me think about there's a lot of great things being said, and people with a lot of excellent experience in this area. And I thought, well, to answer the call that Jacob asked, how do you collaborate with these weird individuals across campus known as engineers? And so I thought we would talk about that. And I think as somebody who I've worked at UCLA, as an engineer supporting space missions. And I am, since 2008, been a professor here at UCLA, on the other side of things, actually being more on the side of applied science than an engineer. And so that's what I want to get at today, is kind of what motivates engineers at UCLA and gets us excited about space. And this is a picture actually of a thruster that I worked on when I was at UCLA, and a little bit after I got here, when I was at JPL, and a little bit afterwards. It's called the Nexus ion thruster, and it's an electric propulsion thruster. And so I'll talk a little bit about that. This is the world's largest ion thruster. And in my lab here at UCLA, because we're the smallest campus with the largest student population in the UC system, instead of a 60 centimeter thruster, I'm working on a 3 centimeter thruster. So, so if we want to think about what engineers do, I thought I'd just give a quick introduction to myself. So when I came here to UCLA, I didn't want to just be an engineer. I really wanted to do applied science. And so I named my lab intentionally the Plasma and Space Propulsion Lab. And plasma came first because I love plasma physics, right? That's what drives me. So in my lab as an engineer, just like all engineers, we have technologies that drive the science that we do, right? And so mine are propulsion systems, and actually I should move my camera over. So propulsion system and space missions and plasma devices and fusion energy. I'm working with Troy Carter on fusion energy. But to do that, really the work I do, we build some thrusters and some plasma devices, but generally we like to do the plasma science behind it, or plasma material interactions, confinement of plasmas, ion-induced and electron-induced secondary electron emission, electron transport, these kind of things. And so that is what drives me. And this is an image of my lab here at UCLA. We have vacuum chambers, and we do some thruster testing, but predominantly we're again doing plasma and material science in the lab. And this is our PI facility where we have a plasma and we focus it down on a material and we look at how those two interact. Okay, so now that I've said that, I'm going to switch gears. What's the anatomy of a space mission? I teach a class. I teach astronautics, I teach space technology and space mission design. And in that class, I teach these space engineers how to conceptualize a space mission. And when it's a science mission, you have to draw another thing on the left. Usually the objective is either to make money, right? If you're a communications satellite, your objective is to make money. And that is usually to, they call them bent pipe spacecraft, where they basically take signals from the Earth and spray them back to the Earth. But in science missions, it's different. A scientist like yourselves will say, I have an objective, right? And I give an example here of Chris Russell said, hey, I want to go to Vesta and Ceres, and I want to look at those. And then he says, how can I do that? And so he says, I need this payload. I need to look at it in this way. So he goes to a place like JPL. I was at JPL at the time. And he says, how can we execute this mission? And I was the propulsion guy. And so I'm working on the bus, and it's literally, think about it, it's a bus that carries your payload, just like a bus carries your kids to school. This bus carries your payload to your objective, and it supplies electric power and thermal control, command and data handling, and communications of the data back and forth, and obviously structure and attitude control, all those different things. But that's what you do when you're an engineer at JPL. And so then how do all these things work together is what we do is again, someone like Chris will come to us and say, all right, here's the payload I need. And we say, okay, what's your electric power requirements, your thermal requirements? And a big thing with Chris is he said, I need to go to 2 asteroids. And the only way we could do that was with that propulsion device that I showed earlier. It was a smaller version of it, but we took 3 ion thrusters and put them on a spacecraft for him so we could get him to go around Vesta and then to orbit Ceres as well. That's what orbits are, they're going around. So he could analyze these. So that's how it works. But when you are, this is just a funny slide I wanted to show. When you are the rocket engineer, you look at a spacecraft and it is a bunch of different systems all together. But when you're the scientist, this is what it looks like to you. You design it, the spacecraft just looks like a big thing to hold your telescope or your diagnostics, right? And so that's the competition that's going on when you're talking about at JPL, you're dealing with all these different subsystems that have to support that payload. So when you're designing a mission, you have to think, if I'm talking to a rocket person, they're going to tell you that the rocket's the most important part of the spacecraft. And I will too. So then, but let's look at that anatomy of that science mission, kind of, okay, we have that objective, but now what does Chris need to do? He needs to go find support. What's the customer? The customer is NASA. NASA says, yes, we'll give you the money to do that. That's great science. Let's do it. We'll give you the launch and we'll give you the ground systems that will communicate with your spacecraft, take your data. Now, this is the interesting part. The engineers that we're talking about that are kind of attracted to UCLA are not the ones that build the spacecraft. The ones that come to UCLA, in my experience, are typically the ones that are more wanting to work with the PI directly on the payload and the new stuff, right? The stuff that is really enabling the mission. And it might be a new propulsion system that no one's ever used before. That would get an engineer excited. But if you're going to say, hey, I just want you to get me there, I don't want any new technology, that's not going to excite a UCLA professor. However, our students, on the other hand, will be excited. So I'm going to talk a little bit about that in the next slide, or in the upcoming slide. So this is a science mission where it is UCLA, it was the Dawn mission, as many of you know. UCLA was the lead, JPL and Orbital. So Orbital built the spacecraft, JPL led and designed the spacecraft, and then you have a lot of support outside of that. And so that's one way to do a mission. Now, but I'm saying that in that, Chris didn't really need to work with the engineers here at UCLA, right? He could if, say, he needed a new a new payload to be engineered to observe. So then, what does this mean? So where was I in all this? So this is what JPL is, right? So JPL's directed by Caltech. And then the people that are doing, of course, we need human resources, business operations, and so forth. But then, of course, what I'm talking about are the engineers. So the engineers at UCLA, or excuse me, at JPL, are here in the engineering and science directorate, which is largely just engineers that are building the spacecraft. But then in the solar system, Mars exploration, astronomy, earth science, that looks a lot like UCLA's basically a science, physics and science, right? So there, what's happening right there is engineers that want to work on the science will interact. They're kind of payload engineers. So they're trying to build that new payload that no one's ever seen before. And basically that, then you can really do kind of breakthrough work in engineering. And for example, if one popular thing for JPL, a payload might be the rover, right? So a robotics professor would be very interested in building a rover, right? Or some of the instruments on that rover. Now, so this is actually stealing from Vasilis. So Vasilis, correct me if anything in here you disagree with, but you know, the anatomy of a space mission, I think really is still PI driven. Vasilis knew that he wanted to look at electrons, right, in Earth orbit and trapped by our magnetosphere. And so what he did is, again, he came across campus and said, I want to build these CubeSats that can do this mission. And it was incredible, right? It was an incredible opportunity. And the part that I think, and I'm using the example of Vasilis because it was very successful. He even built some of the ground systems here at UCLA, one of two Newton systems here for communicating with the satellite, and has a ground support control room here. And where he's going to get kind of most of the interaction from the engineering professors and PhD students and postdocs is going to be more at the mission concept, payload, data collection and processing. And then on Vasilis, I think you'll agree that where we were able to engage the undergrads the most was in the spacecraft bus, right? And we could tell them, hey, you can build the spacecraft yourself. And the scientists too, actually people in your department and in your school actually were very interested in being a part of building the spacecraft so they could work at a place like JPL, right? Lockheed Martin, Northrop Grumman, these different places. So I think that what I'm trying to convey in this message, because really I thought last night, what do I want to say? Like how can we engage engineers of all levels at UCLA, the ones that really kind of see themselves as engineers that do science, or the ones that actually really do want to go work at SpaceX or work at JPL, right? These kind of, so we want to think about those, answering those questions. And so I'm going to end with a couple slides about I have a student group that kind of spun out of Vasilis's project called, now he had Elfin, but we built, what happened was we had some engineers that really didn't want to be part of a mission. They wanted to do what's called a tech demo mission, which is more they wanted to demonstrate engineering technologies. They didn't want to do science. And so that group is called Bruin Space. And I have an ion thruster, this little 3-centimeter ion thruster we're putting on a CubeSat, just like the Elfin sats. But we don't have any intention right now of doing science. We're just, we just want to put a brick up in space and push it around with a thruster, right? That's what gets us motivated. Now, what I would like to say is the people in this audience could say, hey, don't be dumb, put a payload on there. I could put an instrument that could do some great science, right? So that's the kind of interaction I could see happen. That would be great. And then you could tell me, don't just go around Earth, go to the moon and do this, right? So there's a lot of really cool things we could do together. And I'd like to brag about one of our newer faculty, Artur Devoyan. He joined us a few years ago, and he is actually doing solar sail and laser sail technology. And my ion thruster is cool, I agree, but I cannot keep up with this solar sail because he's going to get this thing not at velocities measured in coulombs per second, but rather AU per year type, tens of AU per year. So basically, these things would make Voyager 1 and 2 look like they're standing still, right? So it's just amazing stuff. Now, here's the question. He's working on the solar sail and getting stuff out there. Now, is there someone at UCLA or someone that we know that could put a few grams of a payload on there that could give us the information back that we want? So and the reason I showed this was because Artur is doing great work, but because we don't have something like the Space Institute, we don't have that means for him to communicate with you and say, hey, what kind of science can we put on here, right? And I know that there's so many people that could give us great ideas. And so he actually gave this, now because I like plasma material interactions, this is a paper he just published in May 2021. He's doing basically the radiation material interaction, which gets me excited. He also did a nice job in this paper of talking about the other things that engineers and scientists need to help him with: radiative cooling, broadband dispersion engineering, inverse design methods, ultra low noise photonics, these kind of things. So I think this is what I was thinking. Could the Science Institute be helpful? And I thought, if in the least, people like Artur were able to go up in front of your people and say, look what I can do, or I could show you my ion thruster, look what I can do. And then you guys can say, well, this is what you could do with it that would benefit science. I think that would be awesome. So that's where I see this possibly being very beneficial. So I'll end with this. My thoughts are, there are many ways to get a mission done, and many types of people are needed to do it well. We need to consider individual professional aspirations from the professors to all levels of students. And then I think we need to plan towards the faculty and students we want to attract and the goals we want to achieve, right? So for example, we are not Cal Poly, right? We are not a spacecraft manufacturing assembly line, right? So how do we work that in? I mean, I know Vasilis is, I keep bragging about Vasilis because I have the utmost respect for someone that is a PI like himself, but was able to get a bunch of engineers to work together towards this mission. He was this PI and lead system engineer all at the same. It was just remarkable to see. And I don't think we can always replicate that because that takes a lot of effort. So I think the Space Institute could supply some level of infrastructure that wouldn't require the PI to do all of the work. And actually hopefully leverage the engineers as well. So, and then I just had some questions based off of things I heard. What do we really want the space, you know, based on some of the things I said, but of course, a lot of the things other people said, what do we really want the Space Institute to achieve? Where are the critical areas of leverage? And I was kind of thinking, what are the soft spots? Like, what are the things, because of course we're in LA, right? And we're going to get John Ehrenberg to get a ton of money coming our way. We know it, right, John? And but how do we do that, right? So I think there's soft spots, but we need to exploit those soft spots instead of going after hard spots. The other thing I thought was that we can look at, how do we want to do funding, internal and external, right? I think we do need to seed funding efforts within UCLA so we can go out and get the big money. And and the last thing I wanted to say was, see this third bullet here was collaboration and cross-pollination within UCLA. Again, that's people, you guys telling us where you want to go, and then we can say we could get you there with this technology. And then other things I thought were external models we should consider. JPL, when I was at JPL, I was on this thing called the Eureka team. And what we would do, and this is kind of fun, you get scientists and engineer in a room, and then you say stuff like, we want to do a really cheap mission to Mars to look at the composition underground. And you have these really crazy brainstorming sessions. And out of those brainstorming sessions, one time came the idea that you drop a cannonball from orbit into the ground, and then you watch basically the meteorite like impact and look at so you just come up with these silly ideas, and you eat food and maybe drink a little beer and come up with crazy ideas. But I think that's the type of, if you really want, I think there's a lot to learn from JPL and other institutions. And so, but again, we're still UCLA. So we have to think about which of those things will work for us and which won't. And so that's all. And I'm open to questions and input.
Thanks, Richie. That was really neat. I'm just going to follow up real quick. Just because of your perspective from engineering, I'll give you a quick perspective from the science world, because I speak to researchers a lot. And this was communicated to me directly, but at least one person said directly that his life ambition is to launch a satellite, to have a mission, but he has just kind of no way to do that. So he just does the modus operandi, just write kind of modeling proposals, run his model, and just keep doing that. What he really wants to do is get together with some engineers in a room, do the whole Eureka mission with, Chinese food or however you do it, and conceptualize. And I'll further add that there is great leverage in doing that. I mean, with just organizing properly, it's not unreasonable to land missions that are hundreds of millions or even $1 billion.
Yep.
This is possible. Okay, I've
Yep.
taken too much time. I don't know who was first. Carol Raymond.
Yeah, hi, thank you. So Richie, I don't think we crossed paths when you were at JPL.
No.
I was the deputy PI for the Dawn mission, so worked on that for a long time. And so I know you know John Brophy
Oh, yeah.
well. Okay. So I wanted to make some comments about that at the end, but wanted to start with something that's been on my mind, and you brought it up, and that's that there are other institutions, as you're well aware, I'm sure everybody, that follow these kinds of models of student involved in research and building satellites, operating satellites. Cal Poly is one, Montana State University, Arizona State University, and they've had a lot of success. I think other than Arizona State, I think the others have started up a little more organically. So given that, and then, given the fact that you have JPL being the kind of cauldron of science and engineering collaboration that you're interested in here, I would suggest that the group kind of put some thought into becoming self-aware of what your niche is. And I see it as you have much stronger top level, highest quality research, cutting edge research in science and engineering. And so, somebody like Vasilis comes along and he can make things happen. He's a unique individual and turns, some of this into a beautiful mission. But I think that you need to look at what you have that other people don't have, and then how can that be applied to really, compelling real world problems? Because to connect with the commercial sector and venture capital, you need to know where you're taking this. So I'll leave you with one thought that I got stimulated by Richie's talk, and that's using an ion beam to deflect a small body, which is something that John Brophy's been working on. And it involves a lot of collaboration between science and engineering. Obviously, you have to know a lot about the object you're trying to interact with, and how the ion beam is going to affect it. And the purpose of that, of course, would be if there were a hazardous asteroid that you needed to deflect. So that seems to me like something where you could bring a lot of your expertise, combined expertise, to bear on something that was quite high profile and quite important. So just to summarize, I think some concentrated thought and brainstorming about how you find your niche in this landscape, and who you should partner with when you need to, will really go a long way towards succeeding.
Yeah, I think, and actually one thing, because I have, through Chris and Vasilis, I've been one of the people that has been walking literally across the Court of Sciences to talk with them. One thing, Chris and I told Chris that the ion thrusters on Dawn were 30 centimeter ion thrusters. I told him I now have 3 centimeter ion thrusters. And I said, we can do mini Dawn, and it would be about the size of about a 6U CubeSat. And so we did, he and I, in our infinitely busy minds, threw something together. And really, I think if it were in the context of the Space Institute and we were able to do a little more of the initial studies, because we did propose it to NASA, but it was not as polished as it could have been. So as far as when you're talking about what's your niche, I think that where we could kind of help refine that through an institute where people are talking together and thinking about where are our strengths that we can leverage each other, right? And so I think I was actually shocked we didn't get that funding, but I would say that it was largely because we just kind of threw it together last minute, because we didn't really have the resources to polish it, and even that kind of 6 months of funding to really make a good solid case that I have actually seen. Carol, to your point, these other places do give a little bit of seed funding to their PIs before they go for these billion-dollar proposals, right? Yeah. So I think that you're right. I think that that there is a lot that we could do, but I think also we need to get the professors out of their labs and talking to each other, right? And that I mean, I know that sounds very kumbaya. I know, sure, yeah, they could all work, but I don't think we've even started that except for this conversation today.
Mm-hmm.
And so those people that kind of like you were saying, Jacob, that their life's goal is to do a space mission, they're going to come to these meetings if they mean it, and they're going to be putting in that extra work to do these things.
Also free food.
Yeah, we'll get there, right? We're opening up soon.
And you can serve beer.
Yeah.
Okay, the dean needs to close his ears at this stage.
Yeah.
No, I'm okay with beer.
It's legal.
Okay, John Arnberg and then Vasilis. John, I think you might be
Mute.
good. Yeah.
Let's see if it's.
Yeah, John corrected me. Orbital is now part of Northrop Grumman.
So I'd have to say that conversations, Richie's calling it collaboration, cross-pollination, is one of the first things I would do, and it's very easy. You just get a bunch of people in a room, and I can give you chapter and verse of missions large and small in technology that started with just such a phone call. I built 2 NASA flagships. Each one of them, somebody at some point got up and held up a cocktail napkin and said, this mission started right here in a bar or an airport or something. And so I agree, because I'm on several of those teams at the moment for the coming opportunity. Having resources, not only money, but reviewers and idea vetting will help to develop those missions to emphasize what Carol has rightly emphasized as the cutting edge research that's available at UCLA. That can then be leveraged all of the educational and other goals of the institute that we talked about yesterday. So I don't think this is that hard to get started. I do think that there'll be, some need of people to overcome their fear of standing up in front of a group and putting out a crazy idea. I can tell you stories about telling crazy ideas to big groups of people, but that's how these things start. They almost all start this way. So I think this is an excellent thread to pull on as one of the main axes for this institute. That's it. Oh, and Richie, I have an idea of what you can do with your thruster. I have another mission that might, I'll contact you separately.
Right on. Sounds great, John.
It's working already.
Yes.
Vasilis, please go ahead.
Yeah, I want to reinforce the messages we heard from Carol and from John, that it takes a little nudge, actually, and some coordination to get such projects going and then blossom into larger NASA-funded projects. Because as we heard earlier, some of them require some tender loving care to reach to a point where they can really compete with the others, because they need some attention, some initial engineering, some R&D before they get to a full successful proposal. But that was exactly the model that we used on Elfin. I mean, in 2008, I came in, I had seed funds, and it wasn't my idea sitting in my head. I went around and said, let's get together across all EPSS. Who has a good idea about what to do with the CubeSat, because these things are really neat and we can do great science with them. It wasn't my idea. It was Yuri Spritz who said, hey, if we can spin this thing around, we can get pitch angle resolution and a lot of good science can come out of it. And so we proposed once, we proposed twice, we proposed 3 times, the 3rd time was a charm. But it took that persistence and it took that institutional support to get it going. So the same thing can happen the other way. If you have an engineering idea in need of some, that can support good science, then you can also walk the corridors or have under the Space Institute, have a forum, proposals for new concepts and see what great science we can do and which one we can formulate to address objectives of this or that NASA call. And then assuming the science is great, which I'm sure it will be, then we have a chance of getting it, maybe not the first time, but with persistence, the second or third time. So I think that's a great recipe for success. It does require some initial funding, which is available to other institutions, but UCLA doesn't have its own. And great things can happen with that.
Yeah. Thanks, Vasilis. Really great perspective. We are running about 15 or 20 minutes behind, and I apologize about that, but I think the discussion is just so fruitful and valuable, and I feel like we're just kind of warming up and going, so I don't really want to interrupt it, if that's okay. Okay, any other comments or questions for Richie? That was a really stimulating presentation.
Yeah, I was just trying to say what I heard yesterday and earlier today. I was even changing my slides so as I was getting up, because I was trying to incorporate kind of because I do think it'd be fantastic, right? This is such a because I worked at JPL, I keep saying JPL, but that's where I saw it happen, right? It was engineers and scientists working side by side doing great things, and we can do some version of that. It is possible.
Yeah, and I think I would, oh, sorry, Richie, you were.
Oh, I'm sorry, and we have, but I think we can do it more because it is with something like this, it just sounds really exciting.
Yeah, and I would add that we don't necessarily want to replicate what is done in JPL, but we can streamline ourselves to really work very effectively with JPL. And I think that's probably what we would want to aim to do.
Right, and Northrop Grumman.
Of course.
Yes.
And I'll just note that you have one of the propulsion experts from JPL on the workshop today, Ashley.
Yeah, sitting quietly and just listening for now.
Yeah. Hey, Ashley, I stole some of your charts to teach my students about hybrid rocket propulsion.
Ah, good. You're welcome.
Yeah, there you go.
And just to answer Carol, I thought that was a really good point about, there are other programs, of course, we're not, but there are other universities too. We're not unique, but what does make us unique? In a word, I would say it's just our depth and our breadth. We have so much stuff going on, and we have such a large history. But the question is, how do you really communicate that, and how do you kind of, put it together? How do you, package it so that we kind of make the most use of the fantastic resources we have. So I think that's a really important point to think about.
Yeah, and if I may, I'll just add two further points. You have an incredibly diverse student body, and so that is something you should lead with. Other universities don't have that. Some of the ones that I mentioned, and as well. Managing space missions is an extremely difficult thing to do, as we all know. And, tools or methodologies that could help in that regard that are based in the fundamental understanding of how you manage these first of a kind endeavors that are very complex. I think that would also resonate very strongly with the the wider community.
So if I can just jump in here, I'm listening to the conversation. It seems like the Institute is kind of being defined by this idea that there'd be more science and flights, essentially, right? And maybe that is it, or maybe that's most of it. But whatever it is, my suggestion is that it actually be articulated as part of a pie chart of success factors, right? So more sponsored research. And so then you can drill down into, we want more from existing sponsors and we want new sponsors. We want to be prime, we want to be sub. And then there's a whole kind of attack plan around that with some actual numbers in terms of growth. But then you can also say, but that's one of three things, even though it's the biggest chunk of the pie chart. Here's two others. The other one is more jobs and internships, right? And we got numbers and goals there. And then the other piece of it might be something like more tech transfer, right? And venture capital and spinoffs. And then there's people who go and work that, and that gets looked at and measured. But when you look at the pie chart, something happens when all that activity is actually taking place. There's kind of a brand halo that starts to form, right? A kind of identity that is associated with the UCLA brand and some kind of an institute like this that starts to create lift for all of the initiatives that are under there. And so I wonder if maybe defining some of these sort of key success criteria, right, and maybe how proportional they are in terms of the institutional goals of UCLA, whatever they may be, that starts to set up. I mean, this is kind of a startup, right? So in a startup, you have the 10-point plan, right? How big is your market? How much can you capture? What resources you need to capture it? And what's your return on that investment? And then what's the plan for product, price, promotion, distribution, competition, which was mentioned earlier, and customer satisfaction. All these things are really important in getting the startup through that 5-year, death probability. So I think when you put all this together, you're kind of a startup, and maybe the startup needs a snappy name, and you take it for funding and the whole rest of the process. So this is kind of what I'm seeing.
Yeah, that's fantastic. As far as a snappy name, I mean, it is conceivable that some generous benefactor might want to put a name of himself or herself or themselves behind the institute. That is conceivable. That has happened before. So it's intentionally kind of left a little bit broad and vague as just the Space Institute for now. But I think you make some really good points, and you're absolutely right. It's like a startup, right? It's like a venture, and we're getting together ideas and partnerships from various entities like yourself, Andre, and John, and the various constituents. And I feel like the magic is really, it's really starting to happen. So I very much appreciate that.
Why don't we keep moving along a little bit, and we come back at the end to to have further questions and conversation. Love to hear from Anne.
Okay, is it my turn now?
It is your
like
turn.
I might have negative 20 minutes, but I'll try to go fairly quickly here. So we'll go. All right, is everyone able to see my slide?
Yeah,
okay,
but it's not maximized. Oh, there.
I'm sorry, what?
No, it wasn't maximized, but now it is. Sorry, Anne, go ahead.
Okay. Hi. So good afternoon, everyone. I'm Anne Karagosian. I'm a professor in mechanical and aerospace engineering. And one of the hats I wear is that I'm the director of our joint UCLA Air Force Research Lab Collaborative Center for Aerospace Sciences, or CCAS, which is a rather loosely organized entity. My research is kind of summarized here on this slide. So I work in fluid mechanics, combustion, with propulsion applications. These days, mostly liquid rocket engine, chemical rocket propulsion applications, occasionally plasma propulsion related, but on the computational side, as well as non-reactive flows. But I'm not going to talk to you about that today. I'm happy to talk offline if you're interested. What I am going to talk to you about is this center that we have in collaboration with AFRL that is located at Edwards Air Force Base, so approximately 100 miles from UCLA. And we have a very fruitful collaboration with them that has been rather long-standing. It's actually been, in my case, going on since around 2005 or so. But this collaboration, and this is a snapshot of our website. You can see that the last time we had an in-person event was in February 2020, but we have a number of faculty at UCLA who have research collaborations with the scientists and engineers at the Air Force Research Lab at Edwards. So Edwards Lab was historically created to do rocket propulsion. So this is where the original F-1 launch vehicle was tested the engine for the Saturn V rocket engine. We also do, but they also do, you know, very sophisticated computational studies, very fundamental kinds of experimental studies as well, not only applicable to chemical rocket systems, but electric propulsion systems. So Richie is one of our partners in this collaboration, and he has taken the lead in many of the aspects of it, including a makerspace activity. We have other faculty as well. So let me tell you a little bit about this center, because I think there could be many parallels to the sort of space science entity that you are thinking about and talking about. This is in some ways broader but narrower. So let me tell you a little bit about it. So it's a transdisciplinary collaborative research center. Of course, we at UCLA operate under the fundamental research exclusion. So we pursue fundamental research at UCLA, but also applied research with industry and occasionally with government entities, depending on the circumstances. So a great deal of the funding that we've received from the Air Force Research Lab has been for research collaborations where they fund our graduate students to be engaged in research projects, many of which take place physically at AFRL. So the student will, for example, in my lab, will work for a couple of years, take the classes that are required for the PhD, get through the exam process, also work in our lab on a project that is relevant to and overlaps with potentially what is going on at AFRL. And then after passing the candidacy exam, the student goes out to AFRL, usually, but not always, and pursues a research project there that becomes the second part of their PhD dissertation. There are many other examples of our collaborations. They fund summer internships for undergraduate students, sometimes graduate students. In fact, one of them is a so-called named internship in memory of one of our undergraduates who passed away years ago of cancer, but who was very involved in rocket activities, and you know, he got to know some of the folks out at AFRL, and so they've been kind enough to give us this sort of endowed internship every summer that is connected with a scholarship we have. So the main benefit they get, I mean, they get multiple benefits. Among them are very bright graduate students who will go out there, and undergrads, to do research, and who are physically there, as I say, the last couple of years of the PhD in many cases, but not all. And in fact, it not only develops the future aerospace workforce for our country, it actually provides them with future engineers and scientists. So these students down here, the photographs here, are actually just a subset of my own students and postdocs who've worked out at Edwards. It's now, I think, up to about 15 or so. Some of them will go out there and work for a couple of years, finish the PhD at UCLA. I'll be, you know, the advisor. I go out there periodically and meet with them, or they come back to UCLA. Now, during the Zoom era, these last two fellows are, Miguel Plasencia just finished his PhD a few days ago. And this last fellow is still working on his PhD. But in the Zoom era, now they have weekly group meetings with us. They participate weekly in our research group meetings for our group. But it's provided for AFRL some permanent employees. Some of the students, you know, really love it out there, and they decide to stay because it's this country's premier laboratory for certainly, well, I guess I shouldn't exaggerate, but for chemical rocket propulsion as well as electric propulsion, you could argue, at least along with JPL and other NASA centers. And so it's been a really fruitful, interesting way of interacting. You know, my collaboration started around 2005 or 6. We started this center in 2012 because they wanted to formalize things, but it's a very loosely organized center, I would say. They fund us through two main mechanisms. One is through an educational partnership agreement that gets signed every 5 years, and then faculty propose projects. They make faculty aware of research projects that they're interested in pursuing with us, and then we write proposals. So those go through our Office of Contract and Grant Administration because they're classified as grants. But in some cases, for a variety of reasons, they fund us through subcontracts, through companies, through their contracting companies. ERC is one, Jacobs is another. And so those proposals that we submit go through our TDG, the Technology Development Group. And so, it's a different office at UCLA because it's so-called industry-sponsored research, but the terms and conditions are essentially the same. And the students truly benefit from this experience, even if they want to get the heck out of the Antelope Valley. They meet so many people from, different universities, different laboratories from around the world, actually. And the connections they make are extraordinary. I mean, some of my students, I don't even need to, forward their resume to someone I think might be interested in it. They have their own connections. And I also just wanted to mention, because we have a development person on the call, that actually, because of the visibility of our activities, one of my grad students introduced us to a man who became a donor for our department and who provided funds for Richie's lab, for Mitchell Spearin's lab, for my lab, as well as our student group to build a rocket capability, testing capability and program much greater than what we had previously. I just wanted to mention as well that our department, Mechanical and Aerospace Engineering, interacts extensively with the local aerospace industry. These are the ones that tend to have a space emphasis. I mean, although Lockheed Martin is more in Northern California on the space side of things. But we've had, obviously subcontracts, contracts with many of these companies. FFRDCs are a little bit easier for us to work with sometimes. Aerospace Corporation is shown here. Obviously, JPL you've talked about extensively. We have Air Force Research Lab. I included the Space and Missile Systems Center, which is at LA Air Force Base, although actually that I'm quite sure will be part of the Space Force. But there are a number of mechanisms for collaboration, for students actually to work with engineers at these external entities, engineers and scientists. I will say, so I've been on and off mostly on the Air Force Scientific Advisory Board since the late 1990s. So I work with a whole lot of the companies as well as the Air Force entities. And very frequently when I've heard briefings from places like Aerospace Corporation, in particular, many of the presenters were actually, I mean, lots of them are UCLA graduates, but many of them were not trained in engineering. They were trained in applied mathematics. They were trained in physics or in atmospheric sciences. And so I think this is sort of an untapped, what Jacob is proposing here is kind of an untapped area in terms of putting our UCLA students in touch with and our faculty in touch with entities that would be very interested in the kind of research they do. So that's actually all I'll say. I don't know if anyone has any questions about this.
Thanks very much, Anne. That's really interesting. And before I started this Space Institute idea, I really didn't know very much at all about all the amazing stuff that you guys are doing in mechanical engineering. And, if only to coordinate the activities between mechanical engineering and the space science students under the Division of Physical Sciences, I think that already has just so much benefit. Any other questions, comments? Oh, go ahead.
Looks like Carol has a question, or is
Yeah, I wanted to make a comment related to you talking about untapped potential. My last postdoc, I've had 2 postdocs from UCLA, and the last one graduated from with a degree in planetary science and space physics. Worked on the Dawn mission, so had that experience. And after doing great research on solar wind interaction with Ceres and Vesta, she just entered into a leadership training program at NG. And her interest is in learning more about system engineering and possibly designing and conducting a mission of her own in the future. So that's going in the other direction, where this skill set, because of the kind of maybe unique nature of her skill set, but her very broad experience that she obtained at UCLA and then at JPL, center in a different direction.
Mhm.
Yeah.
Wonderful.
Yeah. So maybe I'll jump here and welcome Dina Lasovsky. So Dina is an engineer. I think you're actually an aerospace engineer. Dina.
I am.
Oh, cool.
All right. But Dina is also a member of our technology development group. And, we invited Dina to tell us a little bit about the perspectives of TDG at UCLA. Please take it away.
Great, thank you so much. And first, I just wanted to say thank you for inviting me, and thank you all also for this opportunity to hear about the brainstorming and your ideas and your visions so early in the process. Sometimes at TDG, we don't get to hear about things until they're a little bit more along the process. And it's just wonderful to hear. I'm very excited about this. Thank you for mentioning that I'm an aerospace engineer. This is very near and dear to my heart, seeing what more we can do in the space sciences. And I guess one thing I would say is that transitioning into my presentation, which will be very short, I promise, it is a little bit more into, let's just call it mundane, to talk a little bit about maybe some logistics and structure. And maybe this is the right time to start doing that, because I want to give you some food for thought about how my office can help once you figure out what you want the research organization, the umbrella research organization, what you want it to look like. Andre mentioned metrics. I think that's really important so that we know how we can help support what you're trying to accomplish, which is just amazing. So again, Dina Lasovsky, Senior Director of Business Development for Physical Sciences and Engineering at Technology Development Group, which is effectively the technology transfer office for UCLA. We do all of the normal things that you would expect a tech transfer office to do: IP protection and management, licensing, industry-sponsored research, business development and entrepreneurship and education. But I want to talk, I was going to give you some data. I'll skip that for now, but I just want to say we're a very high-functioning tech transfer office. Some of you who may have worked with our office a long time ago when it was called other things, we've made a lot of progress since then, and I just wanted to make that point with this slide. There's a lot of activity there. So ways to work with TDG, and I structured this slide to address both our internal customers, faculty, students, and staff, and our external customers, industry, and other types of partners. So there's industry-sponsored contracts, which can be directed research programs, but also helping to form consortia agreements for institutes and centers. I'm going to talk a little bit more about that one because that's a structure you might want to consider for this organization. And that's something that can be structured with IP implications through my office, without IP implications, which might be more under Brooks' purview, but there might be overlaps and we could certainly work together. And I guess another theme that I want you to think of is we will figure out a way to make this work. Whatever structure makes sense, we'll try and help translate that into what framework needs to be in place within the structure of the university and how we do business. But we want to be as creative as you are in making all of this happen. And just to mention a recent example, I think it was Mark that mentioned yesterday the Scale Aerospace program, which is a collaboration between us, UCLA and the MAE department, and Starburst Aerospace. It's an accelerator to help very early stage startups get launched and into the scale. I mean, Starburst. Sorry, I'm trying to go really fast because I feel like I'm going to slow down just a little bit. The Starburst program, and it's something that we haven't really done before. Tim Fisher came to me and said, we really want to make this happen. We think we can get federal funding. Can we do this and work with Starburst? And we found a way to do that. And we're just in the middle of the first cohort there. But one, it's another program that might be able to interact with this program along the way. But two, just something that is completely new that we haven't tried before, and we figured out a way to do it. IP protection, of course, licensing of innovations. We also have a new ventures group, which is one that helps with getting projects from just being a research project, to something that's ready for commercialization. And we do that plus startup support. And we do that through a variety of different mechanisms. These are just a few of them. We have an innovation fund that is really a proof of concept, proof of principle sort of a fund. And it's been focused mostly on the life sciences in the past, but we've sort of perfected that model. And it's something that, if there's funding, could be added to this organization as well that you're considering. I think that's something that could run in parallel and in partnership with a lot of the other things that you've been talking about. But it's another way to take something that needs just a little bit more to be ready for industry, and something that we could incubate a little bit inside. Faculty Innovation Fellows program is a program that we're doing in partnership with Startup UCLA. And that's one where we've talked a lot about education of students, but there's also the opportunity for education of faculty when it comes to entrepreneurship. Obviously, Anderson are experts of all of this, but what we did with this program was help faculty who are not necessarily starting a company, but introduce them to entrepreneurial approaches and topics, even if they have a program that won't ever be for profit. So we worked quite a bit with North Campus programs, but help them seek funding. And maybe it's not venture funding, but it's some other kind of funding for their program. And then we also have folks who want to start companies who are in that. And then there's Startup in a Box as well. So just a moment on consortia arrangements. So again, this is something that can run through gifts or development, but if it's something that has IP implications, it's something that can be an annual subscription program, something like this. Benefits can include participating in your advisory board meetings and steering committees, exclusive member events, workforce recruiting. We've talked so much about how important workforce and students are to our partners, networking and collaboration opportunities, intellectual property, etc. So let me stop there and just see, I shoved a lot into a very short time, so please feel free to ask me questions.
Thank you, Dina. I will add that in physical sciences, we have an initiative that is called the Physical Sciences Entrepreneurship and Innovation Fund, where we do it on our own and also in collaboration with TDG. And when faculty own intellectual property and need a little bit of support to bring their invention closer to licensing, we can help bridge that gap.
I should have mentioned when I said it was focused on life sciences, our innovation fund, it was from an industry perspective, because participation in that fund activity has been extremely high in the life science, physical sciences.
Yeah.
Thanks,
I guess
Tina.
we have time for questions and comments in general, right, Jacob?
Yeah, I think so. I don't want to keep people too late because we're a little bit over time, but I feel like if there are questions, and especially I think I'd like to pick up this idea of the next steps, just so we can wrap up in the next sort of 5 to 10 minutes and let people go. So if there are any questions for Dina, please speak up now, and then we'll transition to the final part.
I will make a comment. Dina correctly pointed out that the new TDG office is really come a very, very long way. I think, there is that used to be a lot of suspicion from the faculty, and I think that there is a lot of support and interaction, and it's a very healthy office. Dina didn't comment, but UCLA the last couple of years, has had the largest number of startup companies of any academic institution, and just the benchmarks have been really sensational. So in physical sciences, we benefit from licensing of a number of major drugs that some of our faculty have developed, and TDG has played a really important role in that. So I think it's a very, very positive relation between the campus attitude towards entrepreneurship and innovation, and how it relates to education and the mission of the university.
Thank you.
Mm. And since you have an aerospace background, I mean, you have to be a part, right? I mean, there's no other way. Really.
I was very excited to get tapped for this project.
Okay, I know that a few people have to go soon. So steps going forward. We will reach out to all our invitees and set up one-to-one meetings if you want to, if you have an interest. If not, and this was just a fun workshop, that's absolutely fine. But we'll be reaching out and hopefully have some conversations offline. And are we generally happy with a follow-up workshop in the next, let's say, plus 4 weeks from this workshop? That's too little, too late? Something like that. Any comments or suggestions about the follow-up workshop?
Your reactions, right?
Seems like it's right on the 4th of July, but you obviously want to avoid that. But yeah, something in that range is probably good.
Yeah, I think that. Yeah, sorry,
I would say for that you probably want to focus on the mechanics and the success criteria, because I think we got a good survey of the capabilities, right? The science and the engineering. So for the next one, you probably want to get into, okay, how do you build this? What makes it successful? Who needs to be part of that? Those kinds of things.
Is everyone comfortable to have kind of a very workshop-y feel? Now it was very much like presentation. If we kind of split up into groups for 20 minutes, 30 minutes or something, with a specific question to think about and come up with some ideas, would that be something that folks would be interested in?
Yeah.
Okay, neat.
All right, I'm gonna have to ring off, so I appreciate the time and thanks for the invitation as well. Looking forward to what's next.
Thank you so much for coming.
Right,
I think we have an initial plan. John, did you have something to add? Your sound is not coming through for some reason.
How about now?
Yeah.
Okay, too many mute buttons. And that goes straight to my comment. I think those kinds of quick workshops are much better in person. A few of us know each other. Some of us know each other better. But I think it's much easier and the dynamics are much better if we're in the same room.
Mm-hmm.
So I don't know when campus is opening up, but I guess the governor is relaxing all the requirements and the colors are going away in a couple of weeks. So I think 4 weeks is a good idea, but in person would be even better. But I do think that we've established all directions are good. Let's pick our the first step in kind of the direction we want to go.
Yeah, thank you. I think that's really important. We actually had a brief pre-chat about this with Miguel, and we talked about a physical meeting. We thought maybe 3 to 4 weeks from now would be kind of pushing it, whether that would be allowed or not. And so we thought it would be safer to do virtual for the first one. But I think the follow-up to that I think we will very much try to make it a in-person one, because for the points you mentioned.
Yeah, I didn't mean to say that it had to be in person, the next one, just that it would be better. It would be better to have a meeting, real or virtual, than skip it and wait 8 weeks. So I think a 4-week cadence is a good idea.
Wonderful. Thank you, John. Okay, so I think we have the next step at least. And from the UCLA side, we'll start doing some work in the background too. We'll just start building it. Are there any final comments before we adjourn?
Just thanks everybody. You know, this has been really very productive. It's been really interesting, and you know, thank you for your support.
It's been a great start. I really think so. Who did I speak over? Sorry, Bacillus.
All right.
So I was going to say thank you, everybody. It's been great. And thank you, Jacob, for all your hard work in putting things together.
Absolutely. It's my pleasure. This is really fun to see. It's really fun. Okay, everyone. Well, I thank you all for your time and your energy. I'm sorry we ran a little bit over time, but I feel it's been extremely fruitful and it's been a wonderful first step. So thank you for everyone who made this happen. Thank you for all your time and effort and energy. And we'll be in touch.
We'll see you soon. Bye-bye.
Okay, bye-bye.